Hey, it's Doc Williams, and in this video, we're going to talk about significant figures and the rules for determining the number of significant figures. The first rule is that every non-zero digit is significant. What this means is that every number that is not a zero is significant. So in the value 132, we have three significant figures. If we have 13.2, we still have three significant figures because we have three numbers that are non-zeros. And it doesn't matter how many, we can have 3,482. In this case, we have four significant figures. The next rule is all zeros between non-zero digits are significant. So if we have 1032, this zero is between two non-zero digits and we have four significant figures. If we have 803, then this zero is between two non-zero digits and we have three significant figures. Another example, if we have 560003, then these zeros are between non-zero digits, and in this case, we have six significant figures. The third rule states that if zeros are trailing a non-zero digit, then they are not significant unless there is a decimal. If we have 130, this zero is trailing, meaning it's behind the non-zero digits, and we only have two significant figures. If we have 130 with a decimal, because now we added the decimal, then we have three significant figures. So now let's look at 500. There is not a decimal, so that means that we only have one significant figure. If we were to add a decimal, then all of those numbers become significant and we have three significant figures. We can also add the decimal between the zeros, and this will be three significant figures because these zeros are trailing, but you see a decimal. So keep in mind that a decimal will make trailing zeros significant. Leading zeros are never significant. A value of 0.032. These are leading zeros. Although they're important for place value, they are not significant in the measurement. So therefore, this will have two significant figures. If I have 0.00032, again, very important for the place value, but only two significant figures. What about 0.0320? These are leading zeros, but this is a trailing zero. So therefore, since this trailing zero is behind a decimal and a non-zero digit, that makes that significant, and I have three significant figures. Now, adding a 1 in front of the value, in front of this first value, makes all of the numbers significant. In this case, the zeros are sandwiched between two non-zero digits, and we have five significant figures, but these two zeros are no longer leading zeros, they are now sandwich zeros, which is why they are now significant. The last rule I want to touch on, which is going to be very important when you're doing your calculations in chemistry and physics, is that counting numbers or counted values and equivalents have unlimited number of significant figures. These are going to be the numbers that are going to be your constants or used during dimensional analysis to convert from one thing to another. An example of this may be 12 eggs, 1 dozen. 12 eggs is the equivalent to 1 dozen. Another one may be 1,000 meters in 1 kilometer. There are 1,000 meters to every 1 kilometer. When using our calculations, these values do not count toward the determination of the number of significant figures. So let's practice. 13 has two significant figures. 130 has two significant figures because this is a trailing zero without a decimal, so it's 2. But if I were to add a decimal behind here, now I have three significant figures. 130.0, that is a trailing zero behind a decimal, making it four significant figures. Now, what if I remove the decimal? I go back to having two significant figures, but if I were to add a number behind those trailing zeros without the decimal, then those zeros become significant, and now I have five significant figures. Going the other way, 0.13. This is a leading zero, meaning I have two significant figures. If I were to add a zero behind this, this is a trailing zero behind a decimal, making it significant. So I have three significant figures, but adding a number in front of the trailing zero makes it a sandwich zero, making it significant. And now I have five significant figures. And keeping this to the side, I want you to tell me how many significant figures are in the value 251. Each of these are non-zero digits, so we have three significant figures. What about 250? How many significant figures? Two significant figures because this is a trailing zero. What will I need to do to this number, 250, in order to have three significant figures instead of just two? Adding a decimal behind the zero will make that into three significant figures. What about 0.25? How many significant figures? This is a leading zero, so that means I have two significant figures. What will I need to do in order to make this leading zero into a significant figure? Change it into a sandwich zero, and now I have four significant figures. So to really test you, what if we had 530.780? How many significant figures? This will have six. This zero is sandwiched between two non-zero digits, and this trailing zero is behind a non-zero digit and a decimal. So both of these zeros are significant. Let's try one more. 0.00789. We have three significant figures. Each of these zeros are leading zeros, making them not used during determining the number of significant figures. Check out our next video where we go into the operations using significant figures. And as always, thank you for watching.